New large, optically bright supernova remnant discovered. Astronomers have reported the discovery of a new galactic supernova remnant (SNR) in the Cepheus constellation. The newly detected SNR is relatively large and optically bright but faint in the radio and X-ray bands. The finding is detailed in a paper published August 13th on the ARXIV preprint respiratory. SNRs are diffuse expanding structures resulting from a supernova explosion. They contain ejected materials expanding from the explosion and other interstellar materials that have been swapped up by the passage of the shock wave from the exploded star. Studies of supernova remnants are important for astronomers as they play a key role in the evolution of galaxies. Disappearing the heavy elements made in the supernova's explosion into the interstellar medium, ISM, and providing the energy needed for heating up the ISM, SNRs are believed to be responsible for the acceleration of galactic cosmic rays. Now a team of astronomers led by Robert A. Faison of the Dartmouth College in Hanover, New Hampshire, reports the discovery of a large SNR in the Milky Way galaxy. The SNR, designated G107.0 plus 9.0, was identified through its optical emission using a 130 millimeter telescope at the New Mexico Skies Observatory as part of the MDW Hydrogen Alpha Sky Survey. G107.0 plus 9.0 was intentionally classified as a faint planetary nebula. However, some studies of the source suggest that it might be an unrecognized SNR. In this paper, we present evidence that this nebula is a previously unrecognized galactic SNR based on its optical emission properties and the structure as determined from wide and narrow HA and images plus low dispersion long slit spectra. The astronomers wrote in a paper, the observation shows that G107.0 plus 9.0 has a new spherical shape with a diameter between 244 and 326 light years, which makes it one of the largest galactic SNRs known to date. The SNR is estimated to be located some 4,900 to 6,500 light years away from Earth. G107.0 plus 9.0 turns out to have an extensive optical emission structure. High-resolution images uncovered a complex set of thin and overlapping filaments along the SNR's northern, western, and southwestern limbs. A few filaments bright in emission. According to authors of the paper, the presence of both radioactive and According to the authors of the paper, the presence of both radiative and non-radiative filaments found throughout the source, and the coincidence of sharp hydrogen alpha filaments immediately ahead of bright emission, along the northwestern limb, as well as its spherical shape, confirm the SNR status of G107.0 plus 9.0. Moreover, the morphology of G107.0 plus 9.0's filament-rich optical emission structure are also indicative of the object's SNR nature. And numerous and delicate filaments seen along its northern and western boundary are matched by few other galactic remnants. Dozens of long and gently curved filaments indicate the remnants' shocks are expanding into large-scale, local interstellar regions with varying pre-shock densities. The researcher explains. The scientists add that follow-up moderate to high depression spectroscopy on bright stars lying beyond G107.0 plus 9.0 could be essential in order to provide more insight in the properties of this SNR.